Hi, well, this shifts gears a little into a little more theoretical realm where we're going to talk about methods or actual finding tests for given distributions. It's not always clear. The examples we've done, they've been clear, but we would like to have some methods. So the first one, a very powerful one and very simple, and so we want to present this at least and do an example or two. So it's called the likelihood ratio test. What do you think it does? It looks at the ratio of likelihoods between, in the case where the null hypothesis is true and where it's not. So not necessarily true. So let's give the definition. So suppose we have a sample of size n of y, and y has an underlying distribution with an unknown parameter theta, which could be a vector, like theta could be actually mu sigma squared or something like that, could be two numbers. And we'll let capital theta sub 0 be the set of possible values that the parameter can take on under the null hypothesis, and capital theta A be the set of possible values that theta can take on under the alternative hypothesis. And we'll let just theta with no subscript be the union of these two disjoint sets. Okay, then we define the likelihood ratio test statistic by, then we let lambda, we'll call it lambda, y is defined to be the ratio of the soup of the likelihoods under, when I'm in this set, over the soup of the likelihoods when I'm in the unrestricted set, so when I include that. So by therefore, it will be always less than or equal to 1. So we'll define it this way: soup over this set, L, and we divide by soup over the full set, the unrestricted set, L theta given y. So one thing should be clear: we have a number here because these are likelihoods, they're non-negative, and this, because this set capital theta includes capital theta 0, and taking the max, or the soup, to be a little technical, essentially you can think of it as the max. This has to include this max, right? So the denominator has to be greater than or equal to the numerator. So this is always a number between 0 and 1. And so we can note that, or you can just remember that. So now we're not even there yet. So that's the test statistic. So now I have to give you the rejection region. So now finally, to complete the definition, any test with RR equals y such that lambda y is less than or equal to k is called an LRT. And here k would be between 0 and 1, is a LRT. Okay, what's the idea here? Does this seem clear to you? The idea here is that if the maximum likelihood, if the likelihood of this sample, the maximum one over all the thetas in the null hypothesis, is significantly less than the unrestricted one. So in other words, it's maybe much higher if I don't look at the null hypothesis, then I want to reject the null hypothesis. Okay, so if this ratio is sufficiently small, I reject it. And this is a very general test. I don't need to be concerned with even knowing how to graph the PDFs, for example. I mean, maybe finding the soups finding them could be tricky, right? It might involve calculus or something, but anyway, this is the enough for my musings on. This is the definition. Okay, all it is a definition. So should we write that down? Our thoughts there. So the idea, we'll say if. So we'll say just how about lambda y will be small, and corresponding to that, H0 will be rejected if the max likelihood on the set restricted to H0 being true is much less, or just less. Well, it's always going to be less than or equal, so let's just say is much less than on all possible values for beta. Actually, all possible values is maybe even a little misleading. What we really should say, because theta, the unrestricted set, theta, the unrestricted set here, is equal to this composition here, this union. If this number is sufficiently small, this means that the likelihood in this alternative set, right, just to be really, so it is actually even more clear, the likelihood in the alternative set is going to be much higher. So idea lambda, so the statistic, the ratio of the two, will be small, and correspondingly H0 will be rejected if the max likelihood on the set restricted to H0 being true is much less than on, let's change this, the set where HA is true. Okay? All right, so all this did was give us this form for the test. So we still have to find K, so let's make another note. So note K is still, like before, resolved by satisfying the type 1 error, by satisfying alpha equal probability type 1 error. Here maybe you could put less than or equal. Type 1 error, this way, right? We'll just leave it equals now. So. Okay. All right. Okay, that's the idea. Let's do an example. Is there time? That whole thing for, yeah, let's do the example in the next lecture. Click on the next lecture.